Hello, everyone. Let's talk about the Parker Solar Probe. The Parker Solar Probe is a revolutionary spacecraft launched by NASA to explore the sun's outer atmosphere, known as the corona, and to investigate solar phenomena such as coronal mass ejections, CMEs. By flying closer to the sun than any previous mission, the probe gathers unprecedented data on the dynamics of solar activity, including the mechanisms behind CMEs and their effects on space weather. Understanding the relationship between the Parker Solar Probe's observations and CMEs is crucial for enhancing our knowledge of solar dynamics and improving predictions of space weather events that can impact technology and infrastructure on Earth. The Parker Solar Probe is designed to reaching distances of about 4 million miles from its surface. This proximity allows it to directly observe the solar corona, where CMEs originate. By studying the conditions in the corona right before a CME occurs, the probe can help identify the triggers and dynamics of these massive eruptions. The corona is the outer layer of the sun's atmosphere, characterized by high temperatures and complex magnetic fields. CMEs are formed when the magnetic fields in the corona undergo reconnection, releasing vast amounts of energy and plasma. The Parker Solar Probe's instruments are specifically designed to measure the magnetic fields and plasma conditions in the corona, providing critical insights into how and the Parker Solar Probe measures the solar wind, streams of charged particles emitted by the sun, as well as the magnetic fields associated with these winds. Understanding the solar wind is essential for predicting how CMEs will propagate through space. By correlating solar wind measurements with CME data, scientists can develop models that predict the speed and trajectory of CMEs as they travel toward Earth. Solar energetic particles are high-energy particles that often accompany CMEs. The Parker Solar Probe monitors these particles as they are released during solar events. By analyzing the relationship between SEPs and CMEs, researchers can better understand the potential impacts of CMEs on Earth. One of the overarching goals of the Parker Solar Probe is to enhance space weather forecasting capabilities. By providing detailed data on solar activity, including the dynamics of CMEs, the probe helps scientists develop better predictive models. Improved forecasting can mitigate the effects of CMEs on Earth, such as disruptions to power grids and communication systems, thereby protecting technology and infrastructure. The data collected by the Parker Solar Probe not only advances scientific understanding, but also has practical applications. As researchers learn more about the mechanisms behind CMEs and their interactions with the solar wind, they can refine models that predict space weather events. This feedback loop between research and application, effective strategies to minimize the risks posed by solar activity. The Parker Solar Probe and the study of coronal mass ejections are intertwined in a complex relationship. The probe's close observations of the sun's corona provide vital information about the formation and dynamics of CMEs, while the understanding of CMEs helps inform solar wind measurements and space weather forecasting. Together, they contribute to a more comprehensive understanding of solar phenomena and their impacts on the solar system, particularly on Earth.